Hello. Guys, in this video, we're going to look at the review. I'm not going to do all the problems, but I'm going to do many of them. So kind of just click through here as you need. You can use this to copy some of the answers from me. That's fine. Try to learn what you can, though, because we are reviewing for a test. But if you want to use this to check your answers, that's how I recommend using this. So go ahead and do the review and then check your answers. Let's look. So here's the review. The first 10 questions are asking us to find the molar mass of elements and compounds. All right, so 1 through 5, we're going to find the molar mass for an element. All right, so let's start with sodium. Number 1 is sodium. Where can we look to get the molar mass for sodium? You guessed it, the periodic table. So let's look at a periodic table, and we'll find sodium. There it is. I'm going to highlight the molar mass. Can y'all see that? So that's the molar mass there, 22.990. So let's flip back to the paper. Where did it go? There we go. So 22.99. 22.99. If I look on the periodic table and find hydrogen, hydrogen's right here, and as you can see, it's 1.008, right? 1.008. Chlorine, chlorine's over here, element 17, if I can see where my mouse is at. That's 35.453. Sometimes I'll round it to 35 when it's convenient, so it kind of just depends. Typically, I would actually round this to a whole number when determining molar mass. I'm usually okay with that, so if you want to round these to whole numbers, that'll save you some time. Now, when you're doing empirical or molecular formulas, I wouldn't round these. Okay. Oxygen is 16, and iron is 56. Rounding to whole numbers. Cool. All right, the next couple of compounds, the next couple of examples are full compounds. So we need to find the total mass for each of these things, okay? So let's do sodium chloride together. Sodium chloride is NaCl. And I don't like that it's doing a double image of my camera. That's a little annoying. Let me see if I can fix that. I don't know if I can fix that. Okay. NaCl. All right, we have sodium and chlorine. The mass of sodium is 23. The mass of chlorine is 35. We're just going to add them together. That is 58. 58 grams per mole. So the unit for molar mass is grams per mole. It tells you how much grams, how much mass is in 1 mole of a substance. Okay. Water, you're going to do H2O. You're going to do 2 times the mass of water, which is 1. So that's 2 times 1. And then you have 1 oxygen, so that's 1 times the mass of oxygen, which is 16. You're going to add those up. 2 plus 16. All right, O2. You have 2 oxygens, 2 times the mass of oxygen. There you go, 2 times 16. Na2O, you have 2 sodiums and 1 oxygen. Multiply them by their respective atomic masses, add them up. So that's 2 times 23 and 1 times 16. Add those up. Okay. Fe2O3. I'm going to let you guys do this one on your own. That's 2 irons and 3 oxygens. So you're going to do 2 times the mass of iron plus 3 times the mass of oxygen. Add all that up. You should get something around 160. Okay, kind of close to 160. All right. So there's our molar masses. That was easy. Determine the mass of the following samples. So the last examples, we figured out how much mass is in 1 mole. Just 1 mole. That's molar mass. It's how much per mole, per 1 mole. The next examples we're going to look at how many grams is in 2 moles of sodium chloride, or 5 moles of water, or so on. So we're going to look at those. So if we have 2 moles of NaCl, 1 mole of NaCl is equal to 58 grams. We did that in the last problem. That was number 6. So back on number 6, we figured out that the molar mass of sodium chloride, NaCl, was 58. So if we have 2 moles of sodium chloride, we know that 1 mole is 58. So we're going to do 58 times 2. And that will give us 117. Or maybe 116. Let's say 116. Okay, 116 grams. So 160 grams will be 2 moles of sodium chloride. 5 moles of water. The molar mass of water, let's write it over here. 1 mole of water was equal to 18 grams. So we're going to do 5 moles of water times 18. All right, figure out what that is. That's what goes there. 2.5 moles of oxygen, O2. O2's molar mass is 32. We did that from number 8. 2.5 times 32. That's what's going to go there. Just multiply 2.5 times 32. 0.5 moles of Na2O. Na2O has the following molar mass. It is 62 grams in 1 mole. If we had 0.5 moles of it, that would be 0.5 times 62. That's what's going to go there. 3.33 moles. Let's write that over here. 3.33 moles of Cl2. Cl2 has a molar mass of 70. So 3.33 times 70. What does that equal to? Write it there. So you'll need a calculator for this, obviously. All right, those are easy too. Ooh, here's a good one. Which contains more molecules, 10 moles of O2 or 10 moles of iodine? 10 moles of O2. If we divide this, if we multiply this by 6 times 10 to the 23, that will give us molecules. So if I'm going from moles to molecules, divide, I'm sorry, did it again, multiply by 6 times 10 to the 23. 6 times 10 to the 23 times 10 gives us 6 times 10 to the 24 molecules. So that's 10 moles of O2. Check this out. 10 moles of iodine, I2. We're going to multiply that by 6 times 10 to the 23 molecules in 1 mole. 10 times 6 times 10 to the 23 is still equal to 6 times 10 to the 24. So both of these have the same number of molecules. Kind of like a dozen. If I had a dozen eggs, I would have 12 eggs. If I had a dozen calculators, I would have 12 calculators. So it doesn't matter what it is. A mole is a mole, a dozen is a dozen. A dozen is 12, you guys know that. A mole is 6 times 10 to the 23. Okay. What else? This is just a little thing here showing you the 2 conversion factors to use Avogadro's number. How many moles are in 28 grams of oxygen? All right, how do we do this one? Let me see how I can do this. So I can probably grab just the question. There we go. and then I can write on it. Maybe. There we go. All right, 28 grams of oxygen. I'm going to write what is given. 28 grams of O2. The formula for oxygen is O2. Let me see how I did this example on my notes. "28 grams of oxygen." Actually, I did just kind of wondering if this is O or O2. We're going to go with O2. If you have oxygen as a gas, it is always in pairs, so it's O2. We're going to go from moles. No, sorry. We're given grams. We're going to go from mass in grams. We're going to convert that to moles. We do that by dividing by the molar mass. So this is what we're going to do. Divide by the molar mass. The molar mass of O2 is 32 grams in 1 mole. So that will go here, 32 grams in 1 mole. I'm going to divide 28 by 32. Again, we're dividing by the molar mass. 28 divided by 32. What do we get there? I got to type this one on the calculator. 28 over 32. That's 0.875, 0.875 moles of O2. And let me actually write that down on my paper before I forget. Because I think I kind of messed this one up. 32. So what do we get? 0.875, 0.875. Okay, there's that one. That's 18. Aren't these fun? All right, what's next? 5 moles of iron. I'll just tell you guys what you need to do here. I'm not going to do this one. 5 moles, you need to multiply by the molar mass of iron. Look on the periodic table. The molar mass of iron is 55, 56. We'll call it 56. So 5 times 56. All right. How many atoms are in 28 grams of carbon? I'm going to write 28 grams of carbon. I'm going to divide by the atomic mass of carbon. That'll give me moles. So in this question, we're going from grams of carbon. We're going to convert to moles of carbon. We're going to divide by the molar mass. Divide by molar mass. And then to get from moles to atoms of carbon, we're going to multiply by Avogadro's number, 6 times 10 to the 23. So that's what I'm going to do next. 6 times 10 to the 23 over 1 mole. All right, notice that the way I set it up, everything cancels. There we go. When we do that, we get Did I not do this one? It looks like I didn't do this one. Huh. All right. You're going to do 28 times 6 times 10 to the 23. So 6 exp 23. And then divide by 12. I get 1.4 times 10 to the 24 atoms of carbon. So if I had a cup or something, and that cup had 28 grams of carbon in it, it would be 1.4 times 10 to the 24th atoms of carbon. Okay. 1.4 times 10 to the 24 atoms. All right, so that's number 20. All right, percent composition. I'll do this first one, and then you guys can do the second one, okay? So let's do this first one. I don't like how I did that. That's messy. That's a little better. That's even better. Okay, we're going to do water. The formula for water is H2O. Remember that the molar mass of water is 18 grams per mole. So that's a mass of 2 for the hydrogen and 16 for the oxygen. Okay, so each atom of hydrogen weighs 1 gram per mole, and so if I have H2, that's 2 for the total mass of hydrogen and 16 for the mass of oxygen. Okay, of course, when I add those up, I get to 18 grams per mole. So what we're going to do here is we're going to calculate the percent hydrogen. Percent hydrogen will be equal to the mass of hydrogen divided by our molar mass times 100. The mass of hydrogen is right here, it's 2. The mass of the whole thing is 18. I'm going to multiply that by 100. I get 11% when I do that. For oxygen, we're going to do the mass of oxygen over the total molar mass times 100. That will be equal to the 16 over 18. Total molar mass times 100 equals 89%. And remember that if you have two percentages, if you know one of them, then you know the other, because they add up to 100. So 100% minus the 11% is going to give us 89. So we didn't even really have to calculate that second one, although we should because we want to show our work. But you can always subtract it from 100. 100 minus 11 is going to give us that 89%. Alrighty. Alright, you guys do the next one, okay? You're going to take the mass of potassium, which is element K, divide that by the total molar mass. The total molar mass of this one is 56 grams per mole. So you're going to take the mass of potassium, which is 39. You're going to divide it by 56, and then multiply that by 100. You'll get your percent potassium. You're looking at almost 70% potassium. All right, then find your oxygen and your hydrogen. All right, empirical formulas. Here's an example that is done for you. I'm going to just work out that example, and then I'll leave this one for you guys to do. So this example here, I'll do on the board here. Now my camera's back. That's weird. I disappeared. We have 25 grams of carbon. We have 4.2 grams of hydrogen and 32 grams of oxygen. All right, so what we're going to do is find our empirical formula. Let me write the steps to finding the empirical formula. First step is to divide mass given by the molar mass. So I'm going to take the mass of carbon, I'm going to divide by its molar mass. I'm going to take the mass of hydrogen, I'm going to divide by its molar mass, or atomic mass if you like. Then we're going to divide oxygen by its molar mass. All right. Then we're going to determine smallest number of moles. Divide, so step 3 is divide all number of moles that you got. We're going to get so many moles of carbon, so many moles of hydrogen, so many moles of oxygen. We're going to divide all of them, all 3 of them, by the smallest number of moles. Okay? And then when we do that, this will give us whole number. This will equal our empirical formula. So that's how we do that. All right. So how do we do that? We're going to take 25 grams of carbon. We're going to divide by its atomic mass, which is 12. That's going to get us why am I not seeing this problem on my notes? Did I do this problem? 25 grams of carbon. I don't see it. Oh, I know why I didn't see it. Okay, let's do it on the calculator. 25 divided by 12. That's going to give me 2.083, and that's going to be moles of carbon. All right, then I'm going to take the 4.2 grams of hydrogen. I'm going to divide by its atomic mass, which is 1. When you divide by 1, you get the same thing. So this is going to be 4.2 moles of hydrogen. And then I got 32 grams of oxygen. I'm going to divide by the atomic mass of oxygen, which is 16. That looks like 2. So that's 2 moles of oxygen. So I get 3 numbers, right? I have 2.083, I have 4.2, and I have 2. I'm going to divide all of them by the smallest number. The smallest number there is 2. 2 is less than 2.083, and 2.083 is less than 4.2, obviously. All right, so we're going to divide them all by 2. All right, when I do this divided by 2, I get something really close to 1. When I divide this, I get 2. When I do this, I get 1. So our empirical formula is CH2O. 1 carbon, 2 hydrogens, 1 oxygen. Okay, you guys can do that next one. Oh, look, we're at the end here. Molecular formulas. Let's do these. I don't know if I have room. I'll try to just do this question. Okay. Okay. Write the molecular formula for the following compounds. An empirical formula is NaO, and the molecular mass is 78. All right, so we know that the molecular mass is 78. We have the empirical formula Na2O. Or what does that say? I can't read that actually. What does that say? NaO2? What is it supposed to be? NaO. It's NaO. Okay. I just couldn't read it. So NaO. So the empirical formula is NaO. So what we have to do first is determine what the mass of that is. What is the molar mass of NaO? And we're going to call it the empirical mass. So what is the empirical mass? So we're going to find out. The mass of sodium is 23. The mass of oxygen is 16. 23 plus 16 is 39. Our empirical mass is 39. All right, watch what I do here. I'm going to take the molecular mass and divide it by the empirical mass. The molecular mass is at 78. I'm going to divide that by the 39. That's 2. So I know that the difference between my empirical formula and my molecular formula is 2. So now I'm going to take 2 and I'm going to multiply it by that empirical formula, NaO. Just make sure that you distribute that 2. You multiply it by both elements. So I'm going to do 2 times the sodium. I'm going to get Na2. I'm going to do 2 times the oxygen, O2. So Na2O2 is the formula for that compound. And I don't really like this question for a reason, but I don't want to talk about it. But I don't like this question. I think it's messed up. All right, we found the molecular formula. Actually, that's the molecular formula. Molecular formula is Na2O2. All right, let's try B. B says if a compound has the empirical formula CH2Cl, the molecular mass is 99. So we know that the molecular mass is 99. We don't know the empirical mass. We need to divide those into each other to determine what the molecular formula is. Our formula is CH2Cl. So that's 1 carbon, which is 12. That's 2 hydrogens, which is 2. And that's 35. So 12 plus 2 plus 35 gets me 49. Our empirical formula here is 49, which is obviously half of the molecular formula. So molecular formula mass over the empirical formula mass, 40, that's 99 over 49, that's 2. So we're going to take 2 times our formula. So I'm going to take 2 and multiply by our formula. I'm going to make sure to distribute. So 2 times carbon is C2. 2 times the hydrogen. That's 2 times 2. That's 4. 4 hydrogens, and then 2 times that chlorine, Cl2. So that's our molecular formula. All right. Isn't that great? And I know that's a lot of steps. That's a lot to do. Find the mass of the empirical formula, divide the molecular mass into the empirical mass, and then multiply it by the empirical formula to get the molecular formula. I know that's a lot. All right, let's see what else we got. We are just about done here. This was way faster than I thought. I thought this video would take forever. What is the molecular formula for this compound? Oh, we're going to do this one. Okay, I'll show you guys a little bit of this one. Actually, I'll leave this one for you guys. This one's got a good little bit of everything. So see if you guys can figure that one out. All right, guys, thank you. Have a wonderful day. Good luck on your review. Let me know if there's any way I can help.